Okay, let's do the chapter 5. First, we need to know the exponential functions. Fx e to the b to the x. B needs to be bigger than 0 and b can't be y. So yb needed to be bigger than 0 and b can't be 1. So if b is a negative number, x can be 1, 2, 3, 4. So if x equals 1 or 3, negative negative b to 1 is a negative number. But if b is 2 or 4, negative b squared is a positive number. So in the graph, the function is like negative to positive to negative to positive. So that cannot be, so b cannot be a negative number. But if b equals 1, fx is like 1 to the x. We know 1 to the every number is still 1. So the function is like the, the horizontal line is not a function to the exponential function. So we got this fx e to the b, fx equals b to the x. B must be bigger than 0 and b need to be 1. B can't be 1. So here is the laws of the exponential functions. B to the x times b to the y equals b to the x plus 1, and b to the x divided by b to the y equals b to the x minus y. B to the x parenthesis to the y equals b to the x minus y. No, sorry, b to the x parenthesis to the y equals b to the x times y, and a times b parenthesis to the x equals a to the x times b to the x. A divided by b parenthesis to the x equals a to the x divided by b to the x. If b is bigger than 1, the graph is like this, is increasing functions. And if the b is less than 1, it's like this, it's decreasing functions. So we have like 5 properties of the exponential functions. First, the domain is from the negative infinity to the infinity. So we can see this two graphs. It's from here to here. It have all the numbers, and here still. Second, the range. The range is from the 0 to the infinity. So let's see the graph. The graph is from here. You see it's really goes really too close to 0, but you cannot touch it. Here still, and it's growing to the positive infinity. So the range is 0 to the positive infinity. And 3 is all pass through the point 0, 1. So we can see it fx equals b to the x. If x equals 0, b fx equals b to the 0. So anyone have the 0 power can only be 1. So it's passed through the point 0, 1. And the fourth one is continuous on negative infinity to positive infinity. So let's see the graph. It's all goes and have no holes, anything. So it's continuous on negative infinity to infinity. So the fifth one is increasing from the negative infinity to infinity if b is bigger than 1, and is decreasing from negative infinity to infinity if b is less than 1. So we can see it on the graph. b is bigger than 1 is increasing, and b is less than 1 is decreasing. So that is all the point of the exponential functions.
Hello, we're gonna start the logarithmic function. It's basically y equals log bx if and only if x equals b to the y. It's only in the intervals that b is greater than 0 and b doesn't equals to 1 and x greater than 0. Second of all, we're going to look at the notation. Log x equals log base bx. That's a common logarithm. And log x equals log ex. That's a natural logarithm. Properties. Log base b m times n equals log b m plus log bn. And log base b m divided by n is basically log base b m minus log b n. Log b m to the n equals n times log b m. And also log b1 of anything equals to 0. And log bb basically is asking you what power it's going to be added to b equals to b. So obviously going to be 1. Hello. So the second part, we're going to start with the properties for the two graphs. B greater than 1 and b less than 1. Okay, so the domain for both graphs are from 0 to positive infinity. And the range for both graphs are negative infinity to positive infinity. And both of these two graphs passes through point 1, 0. Meaning x equals 1, y equals 0. So the point on x axis. And both of these graphs are continuous. And it is increasing for the graph b greater than 1 and decreasing on the graph b smaller than 1. And two other terms. The relationship between e to the x and ln x is e to the ln x equals x when x greater than 0, and ln e to the x equals x for all real number.
Compound interest formula. A equals p parenthesis 1 plus r over m to the mt. A is accumulated amount at the end of t years. P is principal. R is nominal interest rate per year. M is number of conversion periods per year. T is team. Effective rate of interest formula. R effective equals parenthesis 1 plus r over m parenthesis to the m minus 1. R effective is effective rate of interest. R is nominal interest rate per year. M is number of conversion periods per year. Present value formula for compound interest. P equals A parenthesis 1 plus R over M parenthesis to the negative MT. Continuous compound interest formula. A equals P e to the RT. P is principal. R is annual interest rate compounded continuously. T is time in year. A is accumulated amount at the end of T years.